All right, welcome to our first official lesson from grade 8, so Module 1, Lesson 1. We are working with rational and irrational numbers. So make sure that you have your vocabulary done. Make sure that you brush up on irrational and terminating and repeating decimal. Also, so today what we're going to work on is identifying irrational numbers, converting fractions to decimals and showing where they ultimately end up repeating, convert decimals that repeat to fractions, and I can tell you right now that this is going to be a doozy. So really slow down and take your time on that one. We're going to use rational approximations to compare irrational numbers, approximately locate irrational numbers on a number line, and evaluate square and cube roots of perfect squares and small perfect cubes. To be honest with you guys, right here, it's all about memorization. All right, so working on your squares, so squares up to about 13, and your cubes, I would say up to like 10. All right. So first of all, just a little refresher here of how you convert fractions to decimals. So remember, a fraction is just a large division problem. Okay, so rational numbers are written in the form of A over B. So I can take, so like 1/4 here. So here is my A over B, and to turn it into a decimal, I take A and I divide it by B. All right, and I do my long division, and I end up with 1/4 being equal to 0 and 25/100. In this case, I have 1 divided by 3, and I end up with this 3 that just continues to repeat. All right, so I get 0 and 3/10 repeating. Okay. So here we go, moving on to the next part. We are going to practice this. We're going to write each fraction as a decimal. I would like you to do this and then come back and check your answers. So remember, it's like the fraction tripped and fell. The divisor goes on the outside and the dividend goes on the inside. 11 can go into 5 0 times. So I put my decimal in and I bring it straight up and I add a 0 here. 11 goes into 50 4 times. 11 times 4 is 44. I subtract and I get 6. I only add a 0 underneath the division, the long division symbol. I don't add it up top. Okay, and 11 goes into 60 5 times. 11 times 5 is 55. I'm left with 5. Add a 0, bring it down. 11 goes into 50 4 times. Minus 44 is 6. Bring down a 0. Are you starting to notice a pattern that it's going to go into 60 5 times? That's always going to give me 55, and I'm always going to get 5 as an answer. Okay, so I add the 0, bring it down, I get 50. 11 is always going to go into 50 4 times. So I'm noticing here that it repeats, and it's just this 4 and 5 that repeats. So my answer should have been 0 and 45/100 repeating. All right, in this case, I have 1, and I'm dividing it by 8. I know that it can't go, 8 cannot go into 1, but it can go into 10. It goes into 10 one time. 10 minus 8 is 2. I add a 0 and bring it down. 8 goes into 20 2 times. Minus 16 gives me 4. If I add a 0 and bring it down, I know that 8 goes into 45 times, and that's going to work out perfectly, so I won't have a remainder. So I know that this is a terminating decimal at 0 and 125 thousandths. All right, and then here, since I have 2 as a whole number, I know 2 is going to go in front of my decimal, and then I do 1 and I divide it by 3. 3 goes into 1 0 times. I add my 0 and bring it down. 3 goes into 10 3 times. 3 times 3 is 9. When I subtract, I get 1. Bring down the 0. 3 is always going to go into 10 3 times. That's always going to give me 9. It's always going to give me 1 as a remainder. So notice here that I'm having that repetition. So instead of it being 0 and 3/10 repeating, it's going to be 2 and 3/10 repeating because you have this 2 in front. All right, so next we're going to talk about doing this in reverse. We're going to take a look at decimals and how to turn them into rational numbers. So remember, rational numbers have to be in the form of A over B. So they have to be written, essentially they have to be written as a fraction. So in this case, I have the decimal, and if I read it out loud, 0 and 825 thousandths, I can write it as a fraction. So 825 thousandths means that it's out of 1,000, so the place value tells me my denominator, and then 825 is my numerator. I want to write it in simplest form, so I find the GCF of 825 and 1,000. Now in this case, since it is such a large number, I am just going to take a guess since this ends in 25 and I know 1,000 can be gotten to by 25 just because I know, like if I take money, I know that it works that way. So I can do 825 and divide it by 25 and I get 33. And I can do 1,000 and divide it by 25 and I get 40. So 0 and 825 thousandths is equal to, or the same thing as saying 33 40ths. Now, here is the hard part. This is the part where I'm telling you, go slow, all right? So I have 37 hundredths repeating. So what I'm going to do is I'm going to take this equation, so x is equal to 0 and 37 hundredths repeating. If I multiply both sides, so I'm going to show you what I'm doing in red. So I'm multiplying both sides by 100. When I do that, I get 100. Oops, I wanted that to be black. So you can see what I do in red, and you can see my new equation in black. So I get 100x is equal to, now it's no longer 0 because when I multiply anything by 100, I move the decimal 2 places to the right. So this becomes 37, but I still have 37 hundredths repeating because remember, this is what that means. So it means 0 decimal, okay? And then multiplying by 100 means that this decimal moves twice to the right. So I still have this repeating, but now I have 37 in the front. Okay, and then now what I'm going to do, because x equals 37 hundredths, so up here, remember, we have that x is equal to 0 and 37 hundredths repeating. I can subtract x from one side and 37 hundredths repeating from the other side. So essentially what I'm doing is I'm taking this, since I know that to be true, and I'm subtracting it. So I'm saying, okay, well, I'm going to take and subtract x from this side, and since x is equal to 0 and 37 hundredths repeating, I'm going to subtract that from the other side. Okay, so here I have, what I have left is 100 is equal to, and I'm sorry, not 100, I'm losing my mind here. So there's 100 x's over here. That's what that means. So since there's 100 x's and I'm getting rid of 1, that means I have 99 x's left, and over here I only have 37. So then now what I'm going to do to both sides is, since I want x by itself, I'm going to do 99 times x divided by 99. What I do to one side, I do to the other. So I'm left with x is equal to 37 over 99. So 0 and 37 hundredths repeating is equal to 37 over 99. And no, it's not always the case that it's just the number over 99. That's just how it works this time. Again, I don't expect you to understand this right off the bat. We're going to be doing a lot of practice with this. This is a tough one. Okay, so for the first one, we should be able to do this easily. 12 hundredths is 12 over 100. Both of them are divisible by 4. 12 divided by 4 is 3. 100 divided by 4 is 25. So 12 hundredths as a rational number is 3/25. Now I'm going to do the other easy one first because that's what I want to do. It's easy and I know it, so I do it before the other one because that one's hard. So I know 1 is going to be the whole number in this case. And then I have 4/10. So this is 1 and 4/10. However, so it is a fraction, but I want it to be a rational number, and rational numbers have to be written in the form a over b. So since it has to be written in the form a over b, I know that I need it to be improper. So I can also say that this is equal to 1 2/5 to make it a little bit easier. I have one group of 5 plus 2 is 7, so it is equal to 7/5. Now this is only when I want it to be rational, because rational has to be a over b. So just when you got used to taking it out of improper, now I'm telling you that when I'm asking for a rational number, you have to put it back into an improper. So you're welcome for changing my mind on that. And I apologize, because I know it's very frustrating and I know this is hard, all right? So 0 57/100, so in this case I say x is equal to 0 57/100 repeating. And remember, the first thing I'm going to do is I'm going to take it and multiply both sides by 100. So then what I get is 100x is equal to 57 times 57/100, repeating. All right, so this is always my first step. Then I'm going to subtract x equals 0 57/100. So I'm subtracting this whole thing from both sides. On this side, because I have 100 x's and I'm only taking away 1, I have 99 left. Remember, this x doesn't mean that this x disappears. It means that one of the 100 x's disappears. So I have 99 x's left, and here I have 57. I divide both sides by 99, and I get x is equal to 57 over 99. Okay, but now when I look at this, I know, so 5 plus 7 equals 12, so I know both of these are divisible by 3. So if I take both of them and divide them by 3, on the top I get 19, and on the bottom I get 33. So as a fraction or a rational number in simplest form, 57/100 repeating is equivalent to 19/33. All right, now moving on to square roots and cube roots. Make sure that you checked your definitions on these. So with square roots and cube roots, to be honest with you guys, it really comes down to memorization, knowing those square roots and those cube roots for all of your numbers. So your square roots, so like 1 squared is equal to 1. And 2 squared, because remember, squared doesn't mean times 2, it means 2 times 2. So 2 squared is equal to 4. And then 3 squared is equal to 9. So again, practice these. Okay, know your square roots through 12 or through 13. Know your cube roots through 10. What I'm going to do to solve this is I'm going to use what we call a radical sign. And then the radical sign ends up square rooting the numbers. So what I'm saying is if I take this number, and that's a bad example, let's say I take 3. If I square 3, so if I take 3 and I multiply it together, it gives me 9. Okay, well then the square root, so what gave me the 9, the root of the 9 is the 3. So the square root of 9 is 3. So the square root of x squared is going to be x, because x, so basically what it's saying is I have x times x, and here, what times itself gives me 121? Well, I know 11 times 11 gives me 21. So this square root sign basically takes one of each of those away and tells me then that x has to be equal to 11. Same thing here. So I'm saying I want the square root of x squared, and I want the square root of 16 over 169. Well, when I do that, I square root both numbers. So again, I'm saying that I know x times x gives me x squared. And then I have to look at what times what gives me 16. Well, 4 times 4 gives me 16. I can't use 8 times 2 because the numbers have to be the same. And then here, I know 13 times 13 gives me 169. So here, I eliminate one of each, and I get that x is equal to 4/13. Now, with my cube root, it's the same idea. Okay, except for now, and actually, let me go back to square roots. I forgot to mention this part. So remember, when you multiply, a negative times a negative gives you a positive. So in this case, x can be equal to 11 and x can be equal to negative 11 because negative 11 times negative 11 is going to still give me 121 and it's going to be positive since both are negative. So in this case, x can be 4/13 or it can be negative 4/13. So whenever you have an answer that's asking you for a square root, you should have 2 answers. Now, it's not going to be the case for cube roots because remember, when you have 3 numbers, those negative signs do not undo each other and cancel each other out. So here again, I have to basically just know my perfect cubes. All right, so I'm going to take a look here at example 3, and I'm going to try to find the cube root of 729. So what I do is I say, now I don't just want the square root, I want the cube root. So I put a little 3 here. And what I do to one, I do to the other. So basically what I'm saying is I want to know what number times itself 3 times is going to give me 729. Okay, well if I know my perfect squares, that'll kind of help me out. So like if I look at these different options here, so 4 squared equals 16, and 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared equals 64. 9 squared equals 81. 10 squared equals 100. Now I should know my other perfect squares, but in terms of cubes, I'm really only working 1 through 10. So if I look here, I have to think of what's going to be a large enough number that when I multiply it again, so remember, like this means that 7 times 7 equals 49. So then if I wanted to know, so 7 squared equals 49. I want to know if 7 cubed gives me 729. So I need to know if I take 49 times 7, could it give me 729? Okay, so looking at this, we can start to use process of elimination for some of our options because it's really a guess and check. Here, I know that like 1, 2, 3, and 4, those numbers are way too small to even get close. Like if I multiply this again by 1, it's 1. If I multiply this again by 2, it's 8. I multiply again by 3, it's 81. I multiply again by 4, it's 64. So I know these numbers are way too small. So I've got to start looking at larger numbers, okay? Again, 25 times 5, it's only going to get me into 125. So I'm looking at bigger numbers. If I look at 10, I know that for my powers of 10, the larger my power, that tells me how many zeros I have. So 10 cubed, 10 to the 3rd power, is 1,000. So I know it has to be smaller than 1,000. So I'd work my way backwards and check to see if it's 9. So 9 times 9 times 9. Well, 9 times 9 gives me 81, and then I multiply that again by 9. 9 times 1 is 9. 8 times 9 is 72. So I know that 9 times 9 times 9 is going to give me 729. So the cube root then means if I get rid of these extra x's, I know that x has to be equal to 9. Another thing that I can do, so just to kind of help me out, because this is really ends up being guess and check and how well do you know your cubes. So what times what times what is going to give me 8 times 8, or I'm sorry, what times what is going to give me 8 over, where's my pen? There it is. 8 over, what was this one? 125. Well, let's think logically. 1 is too small, and 3 squared gives me 9. So my next option would be 2. So let's check it out. 2 times 2 times 2. 2 times 2 is 4. Times 2 gives me 8. So I know the cube root here, so I know my first one is going to be 4. 125. Well, it ends in a 5. Well, usually numbers that end in 5 are going to be multiples of 5. So why not try 5 right off the bat? 5 times 5 times 5. 5 times 5 is 25. 5 times 5 is 25. Carry the 2. 2 times 5 is 10. Plus 2 is 12. 125. So the cube root then of 125 is 5. So the cube root of 8 125ths is, and why did I write 4? That should have been a 2. Okay, you know what I did? I looked right here. The cube root of 8 is actually 2. There we go. And the cube root of 125 is 5. So the cube root of 8 over 125 is 2/5. Again, practice those cubes and those squares. All right. So here, if I practice my cube roots and my square roots, I know that 13 squared is equal to 169. Or even I know some of us know that 12 squared equals 144. So since 196 is bigger than 144, if I didn't know 13 squared, I could do 13 times 13. 3 times 3 is 9, 3, 0, 3 times 1 is 3, 1 times 1 is 1, and I get 169. That doesn't work. It's too small. So let me try the next largest. 14 times 14. 4 times 4 is 16. Carry the 1. 1 times 4 is 4. Plus 1 is 5. Add my 0. 4 times 1 is 4. 1 times 1 is 1. I get 6, 9, 1. So I know that x is equal to positive or negative 14. That's how you can show both numbers at once. Okay, here again, I take the square root of 9 and the square root of 256. I know the square root of 9 is 3 because I know that off the top of my head. Here, I just figured out that 14 times 14 is going to be 196. So I need something bigger than 14. I know that 15 times 15 is going to give me something that ends in a 5, so 15 won't work. 5 or a 0, I should say, so 15 won't work. So let's try 16. 16 times 16. 6 times 6 is 36. Carry the 3. 1 times 6 is 6, plus 3 is 9, so I get 96. 6 times 1 is 6. 1 times 1 is 1. I get 6 plus 0 is 6. 9 plus 6 is 5, carry the 1, and I get 256. So the square root of 256 is 16. So since I knew my square root's up to 12, it helped me figure out, okay, do I need a larger or a smaller for these squares? All right, so cube roots. Let's go back to thinking about our squares. All right, so in this case, I want the cube root of 512. All right, well, I know that like 1, 2, 3, and 4 are going to be too small. I know 5 is going to end in a 5 or a 0, so 5 won't work. 6, I don't know, so 6 times 6 is 36. Times 6, 6 times 6 is 36. Well, that's not going to work because it ends in a 6. So I can stop there. So let's think of something that when you multiply it might end in a 2. Well, 7 is going to give us 49, right? So 7 times 7 gives us 49. But then 49 times 7, that gives us 63. So that's not going to work because I know the last number doesn't work. So I don't have to go through the full multiplication as long as I just look at that last digit. So let's try 8. 64 times 8. 8 times 4 is 32, so we're off to a good start. 6 times 8 is 48, plus 3 is 51. So the cube root of 512 is 8. Oops, that should go over here. All right, and then now I want the cube root of 64 and 343. All right, well, I know that 8 cubed gave me 512, so I know my numbers need to be smaller than 8. So let's look at 64. I know that 1, 2, and 3 are way too small. Let's see 4. So 4 times 4 gave me 16 times another 4. Well, 6 times 4 gives me 24. And since the number ends in a 4, so far so good. 1 times 4 is 4, plus 2 is 6. So I know that the cube root of 64 is 4. 343. So I'm looking for something that's much bigger than 4, but smaller than 8. So honestly, why not start with 7? So I have 7 times 7, which I know gives me 49, times 7. Well, 7 times 9 is 63. Well, that last digit is a 3, so it's looking good. Carry the 6. 4 times 7 is 28, plus 6 is 34. So in this case, the cube root of 64 over 343 is 4/7. All right, now, irrational numbers. Irrational numbers are numbers that are not rational, meaning they go on forever, but they don't, really simply, they go on forever and they never ever repeat. You can't put them in the form A over B, okay? So basically, any number that isn't a perfect square that's put under a square root is going to be an irrational number. Okay? So the square root of 2, nothing times itself gives us 2. So the square root of 2 is irrational, but we're going to try to estimate its value by looking at where it is. So since 2 is not a perfect square, we know that the square root of -2 is irrational. Irrational. Since we know that it's irrational, we're just going to estimate it. We don't have to find, because we're never going to be able to find it exactly because it's going to go on forever. So I know that that 2 is between 1, okay, and then 4, because we're looking for the perfect squares, so we're trying to find 2 consecutive perfect squares that 2 is between. So 1 is a perfect square. So the perfect square, so like 1 squared is 1, 2 squared is 4. So 1 and 4 are perfect squares and 2 fits between there. Okay, so I know that the square root of 2 has to be between the square root of 1 and the square root of 4. So the square root of 2 is somewhere between 1 and 2. All right, so far I know that it is somewhere between 1 and 2. So we can estimate that since it's between 1 and 2, we can estimate that the square root of 2 is around 1.5. Okay, because about halfway maybe is where that would be. But that's not really that perfect of an estimate. We can take it and plot it on a number line as being approximately here, but remember we use these wavy lines, these wavy equal signs, so this means approximately, it means it's not a perfect answer, not an exact answer. So to find a better estimate, what I'm going to do is I'm going to choose some numbers between 1 and 2, and I'm going to square them. So let's take 1 and 3/10, for example. If I take 1 and 3/10 and square it, I'm going to get, 1 69/100. So I'm basically doing 13 times 13, which is 169. And I would have, because there's 2 decimals here, move it twice to the left, and I get 169. So 14 squared, we said, was 196. So 1 and 4/10 squared would be 1 96/100. And 15 squared is 225. So it would be 2 25/100 if it's 1 5/10 squared. So we have to figure out, is the square root of 2 between 1 3/10 and 1 4/10? Okay. And we're going to say, no, it's not, because 1.5 is not between, get my text here, So no, because it does not fall between 1 and 69/100 and 1 and 96/100. Okay, since we said that it's approximately 1.5, since 1.5 doesn't fit between there, I know that it cannot be between those two numbers. So then now I have to look, is it between 1 and 4/10 and 1 and 5/10? And I'm sorry, I shouldn't have said, that's my fault. Not that 1 and 5/10, it's that 2 is in between. Oh, I'm losing my mind here, ladies and gentlemen. So no, it is, so the square root of 2 cannot be, so no. Since 2 is not between 1 and 69/100 and 1 and 96/100, it's the square root, sorry, I can't make a square root sign, of 2 can't be between them either. That's a better way of explaining it, I apologize. So now, yes, since 2 is between 1 and 96/100 and 2 and 25/100, the square root of 2 can be between 1 and 4/10 and 1 and 5/10. Okay, so now this tells me that since that's the case, since it can be between these two numbers, since it's between 1 and 4/10 and 1 and 5/10, I can look and see that about halfway would be 1 and 45/100. So on a number line, it would be about right here.